Hello ET207 students. This is a video just prior to you taking the midterm exam, which is in this case going to be a CSWA. I've given you some places to go, tips and tricks online, searching online, what to do, how to prepare. Lots of really good resources out there. But I am going to show you a couple things real quick in the next few minutes. First and foremost, part one will be divided basically into three pieces, 33% each, right? The first third being a part that is very symmetrical, one where the origin is something you want to be mindful of, the planes are something you want to be mindful of, the breaking the part down into logical features, small features is going to be the way you want to attack that, okay? The second part is going to be a revolve, a simple revolve. So make sure you know how to do that. You basically are going to spend most of your time creating a fully defined sketch. And once that fully defined sketch is created, you need to be able to revolve that around an origin. I may have time here in this video to show you that quickly. And then the last third of the exam is going to be an assembly. And basically, they're going to give you the parts. You're going to be able to download those parts. And what you need to be able to do is put them together properly so that and each time you create a mate, you should wiggle and jiggle those pieces, make sure it's assembled properly. And when it's completely 100% assembled properly, that means distance and angle mates. So you got to know each of the different style of mates. But all the distance and all the angles are correct. They might ask you, if this angle is this, what is that distance? Or if this distance is this, what is that angle? So that is really the nuts and bolts of the three parts of the exam. You'll have 90 minutes to take it. It is timed. I suggest saving your work often. I suggest making sure your units are right, taking your time, and being very logical about reading through the questions carefully and so forth. So if I expand this first part right here, and let's just say this is a part that you are asked to draw. And of course, yours might be a little more difficult than this one right here, but understand that it's really important that you break things down logically into different pieces. Okay, so an extrude. That extrude then gets cut. That then adds a drill hole, and away you go. Okay, so and each of these has a sketch associated to it that is, in this case, fully defined and so forth. Okay, so very important that you understand the basics, and that's basically what they're asking of you, is to do something like this accurately. Okay, then they're going to test you based on the material. All right, sorry for that potential little error there, but you are going to be tested based on center of mass. I'm sorry, on the mass. So what you need to be able to center of mass in an assembly, but in other words, what is the exact mass of the part when drawn correctly? So they typically tell you what material it should be made out of, and then you have to go to the mass properties to get that number. So how you do that is over on the left-hand side, you'll see right here in the feature manager, material not specified. You need to right-click on that. You need to go to Edit Material, and it'll populate a list of all the different materials out here. Amazing what they have available for you. Let's just say they want 1060 aluminum alloy. I'm going to open up aluminum. I'm going to 1060 aluminum alloy. All of the physical characteristics of that are now going to be applied to this in case we want to test it in FEA or you name it. I'm going to go ahead and hit apply to this. And once that's done, I can close this window, and you can see that 1060 aluminum alloy now appears in the feature manager. If I then go under evaluate, and I go under mass properties, you can see that the exact mass of this in pounds is 0.33. So A, B, C, or D, one of the answers is probably 0.33. You answer that question, go on to the next thing. They're going to probably ask you to make a couple of changes. You're going to have to go in and edit a boss, edit a sketch. What's the new mass? Okay, so that's how you're going to be tested. And there's a sample test for you to be able to take once you create yourself an account in 3D Experience World. Okay, so that is 25% of the test. If I go window, tile horizontally, and we jump to the assembly aspect, okay? So they're going to give you parts. Let's just say they gave you these two parts, and they're asking you to assemble these two parts. You are going to have to go to File, New, go to Assembly, And as long as those parts are opened up first, and remember they are parts, so you cannot have an assembly open on the test and expect to populate parts into it. You need to open the parts up first, then open an assembly. And do not have an assembly open prior, or you're going to have issues downloading the parts, okay? But if they're all open and tiled horizontally, you go into File, New Assembly, and they're going to be populated over here. There's a number of ways you can grab them and drag them over here, or I can just leave this assembly blank. I can go Window, Tile horizontally, and I can do this very visually by dragging pieces in. See that? I just drag that one in, I grab this pin, I can drag that pin in. Then I can open up the assembly and start working with it. First and foremost, the first part that you bring in is fixed. All the other parts, if you had 100 of them, they would all be movable right now, okay? So in order for this part to become fully defined and get mated into that hole, if you will, I'm going to go to Mate. And these mates are all mates that you want to become familiar with. Distance, angle, concentric, tangent, perpendicular, and so forth. Nothing listed over here in the mate selection. So what I'm going to do is I'm going to grab the outside of the cylinder and the surface of this hole, and it's automatically going to populate what it thinks I want. Well, I want a concentric mate. Concentric meaning sharing the same center points. Yeah, sure, sounds great. That's what I want. Accept that. Wiggle jiggle, see what's happening here. I always coined the idea of wiggle jiggle. So this thing still rotates and it moves anywhere it wants to, okay? So the next thing I probably have to do is create a mate that maybe matches these two back surfaces up. Again, the mate selection area is empty over here. I'm going to pick this back edge and that edge, and it just created a coincident mate. And if I hit accept that, now if I wiggle jiggle, the only thing left is this rotation. Okay, and one thing that people are probably a little less experienced with is distance and angle mates. Okay, so get good at distance and angle before you take the test. Practice those. So let's go ahead and put an angle mate in here once. So what I'm going to do is I'm going to try to put this at 0 degrees. I'm going to use this little lever, if you will, and I want that to be straight up and down. So I'm going to pick this edge, and I'm going to pick this edge, and watch what happens. If I zoom out here, watch what happens when I click. 1, 2, 3, click. Uh-oh, didn't do what I wanted to do. Escape. All right, I'm going to do that one more time. I'm going to go to Mate. I'm going to pick this surface, and I know what happened here, but I'm not going to tell you guys. But anyway, watch what happens when I hit this. Hit it one more time. 1, 2, 3, click. You see, by default, it's thinking, oh, Mr. Gutchow, you must want a parallel mate. So it tries to make a decision for you. Don't do that. If you wanted an angle, well, then you go back down to angle here, or you go to angle here. I'm going to go to angle, and it's going to go back to that 30.7 degrees that it was at. Well, let's say we need it to be 45. I can easily, I'm sorry, angle. Angle to be 45. So I type in 45, hit return, and I have 45 degrees there now, okay? So if I hit accept to that, I can look at the 3 mates that I've created. As I hover over them, you can see which ones are which. And you might have this complete. They might now say, given that 30 degrees, what is the distance over here mechanically? Because there's some more parts attached to this. You answer that question, and they're going to say, well, I want that 45 degrees to be 10 degrees now. So you have to go into your mates. You have to right click on it. You got to edit. And I got to change that 45 to 10. Hit OK. You saw how it changed to 10. And now you can answer the next question because you have the thing assembled correctly. Okay, so there I am 9 minutes into this. I've showed you mass properties. I've showed you how to make sure you do simple features with that first part. Making sure you're mindful of planes, mindful of origins. I've showed you a little bit about how to bring parts into an assembly, making sure that you do not have an assembly open first and you only have the parts open, because otherwise you're going to have problems downloading those parts You're sitting there with an assembly open. It's trying to bring parts into SolidWorks, and there isn't a place for them to go, if you will. Okay. And then finally, a little bit about revolves. You will be asked to do a revolve. So File, New. All I want you to do is play around with revolve enough to know that most of your time is going to be spent creating a fully defined sketch. And I would make a center line somewhere like this, and then whatever I drew, as complex as they give it to you, of course you have to get it right, but I'm just going to say this is a pulley, right? And they gave you all these dimensions right here, and you have them all completely correct, and mine aren't. And they say, I need that to be revolved, and it has to become a pulley. Well, if I go under Features, and I go under Revolve Base, and I say yes, because it's going to go around this center line, I immediately have a pulley. And it is defined by that sketch right there. So as I make edits, there it is, finished, okay? I can go in and edit that as long as, and again, this one's not fully defined, but as I make changes to it, you can see that it takes on whatever dimensional changes I make to that immediately. Okay, so play around with revolve. You'll be asked to do a revolve on the test. You have 3 things you have to do. Window tile horizontally. You will have a very symmetrical part, like this guide block that you have to make. You will have a series of parts that they give you that you'll have to put into an assembly where you have to understand some things about distance mates and angle mates and be able to answer questions about that assembly. And you will be asked to do a revolve, build a part following the blueprint. So you have to do some blueprint reading and understand dimensions, radiuses, and all the rest. But ultimately, you will also be tested for the revolve and the first part based on their mass. So you need to know how to add material, 1060 aluminum alloy, raw iron, plastic, whatever it might be, and then go up under the evaluate tool and go to mass properties and find out and know what the exact mass is of that part based on the fact that it's made out of a certain material. Many will forget to change that material, and they'll rush and they'll go, like in this case, material not specified, right? You can still go to mass, and it's going to give you a mass that is exactly wrong. And A, B, C, or D, one of them will be 270.91. And you will be 100% wrong because you never changed the material. So little things. Take your time, have fun with the test, and then I'm going to leave you with this. Many do not pass part 1. Know that you can get a very good grade in this class. You can get an A in this class without passing the CSWA exams. We want you to try. We want you to put 90 minutes in, do your best, learn from them. As you go in and you do part 2, you're going to do much better, most likely pass part 2, and you'll have an opportunity to come back and retake part 1 if you choose. You don't have to. And like I said, you can get an A in this class without passing the test. See it as an opportunity. SolidWorks actually calls the test vouchers opportunities now, so they give you a test opportunity, not a test voucher. They are worth about $100 a piece. You get them for free, so you are going to be taking hundreds of dollars worth of testing for free. And it has value beyond school. It is relevant. It's the largest mechanical engineering software in the world, used by more engineers anywhere in the world. 8 million and counting. One of the early questions they ask you is what language you want to take the test in. And I believe you have 12 or 13 languages to pick from. Good luck on that test. See it as an opportunity. Don't get frustrated. Remember that the project is by far the biggest item that you need to be concerned about, and most everybody does just fine on it. Good luck. If you have questions, email me. Good work up to this point. People are turning things in on time, getting assignments turned in. So enjoy your break after this test opportunity. Talk to you later.